All right, so we're going to continue on with the solar system. I forgot all the little noises I put on this. Okay, so we already learned about the sun and how the sun is the center of our solar system, right? And all the planets orbit around it. Now we're going to talk about the planets individually. You guys have your project that is coming up in due date in a couple of weeks, right? Don't forget that. Make sure you guys are breaking up. At this point, guys, you have broken up the project with your group members. If anybody has not, I highly suggest you do that because you do have this Christmas break that's coming up where you can do your part and be done in a day, okay? At least that way you won't have to worry about it. You take one day and that's it. You guys earn those extra 2 days off before Christmas. Might as well get that all done. All right, so let's talk about the planets, right? So the definition of a planet is that it is a body that is in orbit around the sun. Okay, so it has to orbit around the sun. It has self-gravity, okay, to overcome the pull or the gravitational force of any other planets, okay? And the fact that it says it clears the neighborhood around its orbit, it just means that there shouldn't be anything that's in the orbit with it. So that's the problem with Pluto. It's one of the major planets with problems with Pluto, right? Does it orbit around the sun? Yes. Does it have enough mass for self-gravity? Yes. But it does not clear its neighborhood, right? Its orbit overlaps Neptune's orbit, right, which ends up being a problem because that's one of the reasons why they say Pluto is not a planet, at least in our solar system. They are calling it a dwarf planet because there are some characteristics, like it does have the gravity and it does have enough orbit, or it does orbit around the sun, but it's not a full-fledged planet. Okay, so we should know this order by now. It goes Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So it's my very educated mother just served us nachos. Okay. If you don't remember this, where can I find it?
The reference table.
What page?
I think it was 15.
Right, exactly.
What reference table?
Absolutely. It's reference table, page 15. Now, in between Mars and Jupiter, what's right here? Not one of the planets, but there should be something right here.
Asteroid belt?
Right, that's the asteroid belt, exactly. What are the 4 inner planets known as? What's another name for them when you group them together?
Terrestrial.
Terrestrial. What are the 4 outer known as?
Terrestrial.
Jovian.
Right. So the inner planets are terrestrial. The outer planets are Jovian. J for Jovian. J starts with Jupiter. Okay? That's how you're going to remember it. All right. So when it comes to these specific slides, guys, I'm putting up a lot of information. You are not required to know all of them. However, you are required to know the ones that I tell you. A lot of this information is on reference table page 15. Remember that. So it's not something you have to memorize. I'm going to tell you the information you have to memorize. So on these slides, there's a lot of information, but you're not required to copy them down because things like the rotation, the revolution, the eccentricity, the density, the size relative to Earth are all listed on the reference table. So you don't have to memorize them. So Mercury, what you do need to write down, guys, is the atmosphere, the landscape, and the temperature, okay, and the number of moons. So the atmosphere, if there is one, the landscape, what it's made up of, the temperature, and the number of moons, if there are any, okay, because those are not on the reference table, all right? So Mercury is the closest planet to the sun, right? It has very little atmosphere. So if it has very little atmosphere, when we get up close and personal to it, what do you expect to see?
Craters.
Exactly. Victoria, is that you?
Yeah.
Good job. Okay. So you would see craters. Why?
Because there's nothing.
Because since there's no
Exactly, you both have it. Okay, because there's no atmosphere, right? There's nothing protecting the planet from asteroids that come in, or just not moon rocks, just stuff that's in space to come in and hit the side of it, right? Where we have a very nice atmosphere that protects us from those asteroids, or at least will burn them down to a smaller size, so it doesn't really hit us as hard. Okay, so what is it made up of? It's made up of craters, a little bit of ice, and you can actually see cliffs and valleys, right? Because it's so close to the sun, during the day, it is ridiculously hot. Not a place that we could live, because it's hundreds of degrees below freezing at night, okay, and ridiculously hot during the day. All right, so those three are really what's important. All right, so that's Mercury, right? It has no moons and no rings. Mercury. Okay, so let's talk about Venus. Oh, wait, never mind. I lied. So let's talk about its interior a little bit. All right. So you have the inner core, then you have the outer core, right? That's how all the planets work, basically. The inner core is about 3,600 kilometers in diameter. Notice how we're using kilometers and not astronomical units and not light years, right? Because we're talking about a planet itself. We're not talking about in between a planet and the next planet. Okay, so it is still using the distance that we would use on Earth as well. Okay, so it has an inner core, an outer core, the mantle and crust. The mantle and crust is only about 500 kilometers thick, so it's not very deep. Okay, so just like Earth, right, some of the core is going to be liquid. So some of the inside is going to be liquid, and that's going to produce a magnetic field. They were talking about it yesterday, and how on Earth, because of the way the magnetic field was yesterday, you could actually see the aurora borealis in New York. I was watching the news yesterday. We couldn't necessarily see it because it was still super cloudy and you have too much light pollution, but it actually allowed it to come down, and it pulled down on some of the lights, which is pretty cool. Okay, so this kind of looks familiar. It's kind of like Earth's, right, where you have a core and then you have a crust and a mantle, right? But notice that the core is very large for Mercury, right, versus our core, right? We have the inner core, the outer core, right, and then we have the crust all the way over here. So it's similar to ours, but not so similar that it's identical. Okay, so like we were saying, right, since there's no atmosphere, you have craters and cliffs that have been created. Those are known as escarpments. Okay, so it's because they have no atmosphere that the surface is going to be covered in all of these craters and cliffs. Okay, some of the escarpments or the cliffs were created after the craters were formed. And how do they know? Because they actually will cut across it. So it's kind of like if you are, what's the best way to explain it? If you are building a house, right? And you build the outside of the house, but then you realize, okay, I don't want my house to be 100% brick. I want it to be brick and then siding, let's just say, or stucco, right? You can actually see that there was a layer of stucco over the brick. Okay, that's how you know it came after, right? So the same thing happens here. Okay, that the cliffs actually are shown that they cut across the craters. So the craters were created from these asteroids and other space stuff that came in and hit into Mercury, right? Okay, and then the craters, the escarpments actually cut across them, which means that the craters were older than the cliffs. Okay, Not only do they have these craters and cliffs, but they also have other relatively smooth parts of the surface. Okay, we call those plains. Plains are just flat, smooth surfaces. Okay, this is interesting that they actually found ice inside of the craters because it is so close to the sun, you would expect it to not have ice. But because those craters are so high up, it blocks the sunlight. Back to that first slide, it said that the temperatures in the dark zones or at night are hundreds of degrees below freezing. So the same thing's going to happen on the inside of these craters if there's no sunlight that comes in. It's going to be hundreds of degrees below freezing. So you can actually form ice, which means that at some point there was some sort of liquid water there, right? That because you have to have water in order for ice to form. Does that make sense, guys?
Yeah.
Yes.
Okay. So that's what it looks like. That's a satellite picture. To me, this kind of looks like the moon, right? But it's not. This is actually the surface of Mercury. Now, looking down here in this bottom left corner, you see how there's these two craters, but they're pitch black, which means that the crater is so high up versus these other craters where you can still see the bottom of it. See, there's some more that are pitch black. So that's probably, if I had to guess, that's where they're finding the ice because there is no light that's hitting it. Here's just another picture. See, to me, this looks like the moon the way that the picture is. If you gave me this picture and another picture of the moon, I probably wouldn't have been able to tell the difference. Let's see. Which one do we want to watch? Let's watch this one, if it works. Okay, so you can see Mercury moving across the sun. This one's not as much fun. I have posted for you guys, just so you know, a ton of these videos on Google Classroom. Let's see. All right. This is just some information that goes back. A couple of pictures, which are really cool. All right, so this is the smallest planet. So there it is in comparison to the other planets, the other terrestrial planets. Google Classroom, along with all of these other ones. Okay, so let's talk about Venus. Venus is the second planet, right? Again, you don't need to know the mythology. It has no moons. The diameter is listed on Earth Science Reference Table, page 15. The surface, again, you have volcanic activity, which is going to create that cloud covering around it that we talked about the other day, right? That cloud cover is creating a greenhouse effect on Venus, which makes it the hottest planet in our solar system.
Do we need to copy down any of this?
The moons, the surface, the temperature, and if you want to put down the tilt. Right? Everything else.
What was the last one?
The tilt.
All right.
Everything else is on reference table page 15. Okay. So it's got similar of a tilt that we do. It's a little bit more, right? But the biggest problem is because it has that cloud covering around it, so it's really hard to get satellite images of Venus. Okay, that volcanic activity is going to create the cloud that surrounds it. Now, because of that cloud, it traps in the heat and creates that greenhouse effect that they are so worried that's happening on Earth. Okay, because they see what it's doing to Venus. Venus is basically uninhabitable for humans. Okay, look at the surface temperature. It's 460 degrees Celsius, right? Water boils at 100 degrees Celsius. So just put that into perspective, how hot boiling water is. The surface of this planet is almost 5 times more than that. Okay. All right. So like I said, it has no moons. Its average surface temperature is 460 degrees Celsius or 867 degrees Fahrenheit. Okay. Everything else you already have on the reference table. Okay. So Venus is going to be one of those brightest objects that are visible from Earth. Okay, it's called the morning star because you can see it, especially as the sun is rising. All right, I think I posted a picture of it for you guys. No, I posted a picture of Mars on Google Classroom for you guys the other day. Most of the time when you look at next to the moon will be here, and then you'll see a star, or what you think is a star. It's actually Venus. A couple of times this year you will see it. I suggest, guys, if you look at the moon at night and you see a really bright star, take out your phones or your iPads and go on the night sky app, okay, and see if it's Venus. It might very well be Venus because you can see it just as the sun is rising and just as the sun is setting. Okay. So here's a picture, like I was saying. You see how the sun is, I don't know if this is, I think this is setting, okay? Here's the moon, and then that right there is Venus, all right? It looks like just another star, but it's much brighter than the rest of them from our perspective. Here we go again. Here's the moon, and then down here is Venus. It's just depending on where you are. Usually from us, Venus is to the right of the moon, usually, but it depends on the time of year. Okay, here we go again. Here's the moon. Okay, here's Venus, and then I'm guessing this is another planet. Okay, so this is what the surface of Venus looks like through an infrared camera. Okay. You can see that there's actually some, it almost looks like there's some rivers here, but I doubt it's rivers. It might be channels where water used to be. Okay. The hotter spots versus, you see how it's all different colors? That tells me that there's a very hot spots, and pretty much that's it with Venus. All right. So it's mostly going to be molten, right? Fun times. Okay, so let's talk about its atmosphere, right? There's this thing known as atmospheric pressure, right? Actual atmospheric pressure on Earth is 1 atm. So it is 90 times that of Earth's. Standard pressure for us is 90 atm, all right? This is why we can't live there. It's made up of 96% carbon dioxide, 3.5% nitrogen, and less than 1% is made up of sulfur dioxide, which would kill me, water vapor, carbon monoxide, which would kill everybody, and argon. Okay, so we can't live there because of it. That sulfur dioxide, though, gets into the air based on the volcanic activity. Okay, that's one of the side effects of volcanoes erupting. Okay. All right. like I said, it has the highest surface temperature due to that greenhouse effect. What's happening is it's allowing some of the sunlight to come through, but not escape. So a greenhouse basically is usually a glass structure where you want to grow vegetables or fruit or flowers. If you're a florist, especially, they like to do that so that you can get flowers that don't normally bloom. Bloom in like December. You'll have them for that special occasion that comes around. It's a glass structure, and it allows certain type of radiation in, and others get bounced around on the inside when it changes. It will not, it basically, if you ever go to a greenhouse, it's nice and toasty and warm inside there, even if it's freezing outside, because that sunlight gets absorbed through the glass, it gets absorbed into the plants or whatever it is, and as it comes back out, it comes out as a different wavelength of radiation. Okay, so we have UV radiation that comes in from the sun, it gets changed in the soil and comes out as infrared radiation, and that infrared cannot come out of the greenhouse effectively. You want it to ends up getting trapped in there. And when that happens over and over and over again, you increase the temperature of the planet or inside the greenhouse itself. And that's the problem. Okay, so you've seen our version of this, but now this is a version on Venus. Okay, so here is their troposphere. I would die right here, and then I would die again right here. Okay, I'm highly allergic to sulfur. So anything that says sulfuric, it has sulfur in it. It's a problem. All right, that's all because of the volcanic eruptions that keep happening. They create that surface. So like I said, right, here we have the greenhouse effect. The sun's rays come down into it, right? And as it's trying to leave, it actually bounces back into the surface of the Earth, okay? So this is what's happening basically on Venus. The difference is that on Earth, some of the infrared radiation will leave. Here, it's not. Okay? So Earth, you should know Earth by now, right? You kind of live there, right? We have one moon. Okay, you know that we're made up of mostly water. Who remembers what percentage we're made up of water?
Isn't it over
I heard
70%?
it. It's 70%. Who remembers how much of that is drinkable?
Less than 1%?
Oh, it wasn't 1%.
Isn't it
3?
3%. Good. You guys remember. Great. Yay. Okay. So a lot of this stuff you already know. So it shouldn't be hard for you guys to actually remember this stuff, right? Other than, you know, we're the third planet from the sun, right? We're the only planet that has liquid on its surface, right? Everything else, almost all the other planets or some of the planets have liquid inside of the planet itself. We're the only one that has like water on the outside, okay? And so far, we're the only one that is suitable for life that they have found, okay? We have no rings, right? There we are. Okay, Mars. Mars is fun, all right? Mars is only 10% the size of Earth's, right? So it's a small planet. Even though we're looking into it to colonize it, we're looking into colonize it because of the fact that it has a similar tilt to us, and it has everything pretty much except for the massive amounts of water that we have, okay? Mars has 2 moons where we have 1, all right? And it's 1.54 astronomical units away from the sun. So if you're looking at this, right, they basically, that's listed on the reference table for you. Okay, so let's talk about the atmosphere of Mars, all right? Its atmospheric pressure is 1% of Earth. So that comes into being a little bit of a problem when we're talking about pretty much everything. So chemical reactions or in general, that just becomes a problem for us. If we do colonize it, we may have to build like a bubble so that we can change the pressure, right? Because if there's less pressure, then the molecules can move out. Part of the reasons why astronauts wear those spacesuits is to basically create a little pressure zone, besides getting the oxygen, but also to create a little pressure zone so that your blood and the molecules that are inside of you don't try to escape outward, right? If you've ever heard of depressurizing the cabin on a plane, what's happening is as you're flying upwards, the reason your ears pop is because the pressure is changing, okay? If they did not keep the pressure equal, or equalize it, I should say, then you guys would all just go and explode. Fun times. Okay, so the atmosphere on Mars consists of 95% carbon dioxide, 3% nitrogen, 1.6% argon, and traces of oxygen and water. Now, scientists are holding on to the fact that it's traces of oxygen, because what that tells them is that you can create more oxygen and it's sustainable on the planet, right? Even though right now it's 95% carbon dioxide, if we go there and we start colonizing it by planting greenery, that carbon dioxide will then be turned into oxygen through the process of what? What process is it, guys?
Photosynthesis.
Right, photosynthesis, good, right? You have all this carbon dioxide there, you just need to harness it to create more oxygen for humans. Now, we can do that if we can figure out how to get people to Mars, because remember, it's a one-way trip, and you don't know if it's a death sentence yet or not. But the fact that they have oxygen already in the atmosphere gives us hope that we can colonize it, okay? Because that means that oxygen will stay there, and it can be usable. And the fact that it's found water, okay? It doesn't really have weather patterns like we have. Like yesterday, it was snowing. That was interesting, okay? I mean, it is December. It should snow. So it doesn't really have any crazy wind patterns. Crazy storm patterns other than they have wind storms. Okay. Here's a picture of Mars from a satellite. Kind of cool. Right. There's a picture of those crazy wind storms that we were just talking about. Right. But again, when you're going onto a foreign place, you don't know what's going to happen. Right? All right, so the reason why it's red is because it has a high iron content. The symbol, the chemical symbol, and I want you to write this down next to where it says iron, is capital F, lowercase e, and I am actually going to, maybe not, because it's under like 70s, huh? All right, we're going to put it right here. Capital F, E. You should know that. Live it, learn it, love it. That's one of the places, or one of the things that you should know the chemical symbol for. It's going to show up a million other times. Come on. All right, I'll cancel it there. Cancel. Okay, so it's got this rocky surface. Okay, when you are, right, it's cratered. So what does that tell me about the atmosphere, guys?
It doesn't have an atmosphere.
It does have an atmosphere. It's just going to be much less than Earth, right? Again, here's another plus in the column for Mars, right? It has a gravity that is similar to Earth's gravity, right? So that means if we can go walking on it, we're not going to go flying away, and we don't need any turbo boosters. I'll go back so you guys can write that down. All right, so the reason that it has that red appearance to it is because of that high iron content. You guys have actually seen it before. Have you ever seen rust?
Yeah.
Right? You guys have seen it if you're walking down Peck or other places. If somebody hits the side of their car and all of a sudden water gets to it, it starts to turn from whatever color the metal was to that orangey reddish appearance. That's the iron content. Okay, the more red it is, the more iron you have in there. Okay, so again, here's just a picture of it. Is it bad that I kind of want to see like the rover driving across this? I feel like it's one of those surfaces that people go like extreme driving on.
I have a question.
Sure.
So since they have like less of an atmosphere than Earth and they want to like make it livable, wouldn't the people be in more danger there since craters, like since meteors and stuff have an easier target opinion and stuff?
Right. So one of the things that they are hoping is that they can change the atmosphere. Because remember, right now the atmosphere is extremely high in carbon dioxide and extremely low in oxygen. If we go there, we'd have to keep that in mind for at least the first probably couple hundred years. You know, we'd have to build a structure of some sort that would keep us protected from those kinds of attacks. You know, and then hopefully we can change the atmosphere a little bit. Okay. At one point, Mars's surface was completely covered in water. All right. How do we know that? You always can't just say, hey, you know, like it's covered in marshmallows. Well, how do you know? Right? You have to have evidence. They have channels and valleys and proof and where water has actually flown through. You can see that they're cut out in such a way that's similar to Earth. Okay? The difference here is that most of the water on Mars is locked up in those polar caps. Okay? Or at least at the time. I want to show you a picture of the valleys and channels. Okay, so here's Mars's surface. You see this ripple effect here, right? It's the same kind of a ripple effect that you see in rivers on Earth. What that means is that the water was going over it, and you can see where the sand was built up. You can also see, if you look on either side here and here, a little bit over here, it actually wore away at the rock that was next to it. So the only thing that can do that in this particular way is water. Again, here we have that ripple effect, and we also have the channels that go down like this. Okay. So this is what they think that Mars looked like when it did have a lot of water on it. Okay. All right. So there is a very, 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 very large volcano on Mars. Okay. It's called Olympus Mons. Okay. It is 15 miles high. Now, putting that in perspective, Mount Everest, which is the highest mountain on Earth, pretty much, is only 6 miles high. So that's more than double that. And this is a satellite picture of what it looks like. Look how large this is. Look how wide this is. Right? You can see the cloud cover. Right? It's crazy when you think about it. Right? There's a picture from the rover. Right? There's the sun. Fun times. All right, so let's talk about their moons. Okay, so there are two moons. One is called Fear, and the other one is called Dread. That's nice and cheery to me, right? It's Phobos and Deimos. Okay, they think that these two are actually from the asteroid belt that got pulled into Mars's gravitational pull and are now orbiting around it. Right? So I'll go back for a second. The reason they think that they were probably asteroids is because they don't have similar shape to a planet. Okay, they're oddly shaped, right? They do have craters on them, right? But if you're looking at it, it's not a round shape, and it's not the same kind of shape where if something hit it and then took parts off of it, it's just an odd shape, right? All right, guys, so I'm going to end here because the bell's going to ring in a minute or right now. Okay, so we will start with asteroids and the rest of the Jovian planets tomorrow. All right, you guys have a great day.
Have a good day. Bye.
Have a good day.